Our next speaker is Matt Royer from Penn State. Matt has a law degree. He has a bachelor's degree in biology. He has 20 years or so of experience in all kinds of areas of environmental stewardship, and he's very much involved with the Susquehanna Watershed and with management of contaminants from agriculture and other sources. So he's going to talk to us about collaborative community engagement strategies to achieve healthy watersheds.
Thank you, Val. Appreciate it. Good afternoon. I'm happy to be here. My name again is Matt Royer. I direct Agriculture and Environment Center at Penn State in our College of Ag Sciences. And we work a lot on the broad-based landscape, the land, and work with aspects of land use and land management in agriculture and urban settings, and how that land management impacts the health of our water bodies, water quality. So a lot on nutrient pollution. So David, I was right with you on the cow talk at parties, because I don't know how many times I've been in cocktail parties. My wife will saunter up and say, "You're talking about manure again," because every conversation goes back to manure with what we do. So I could appreciate that. So I'm going to talk a little bit about manure today, but other aspects of land management, and again appreciate the opportunity to speak with you about these issues. We're going to talk about the challenges of addressing non-point source pollution, because it's not an easy issue. And it was Allison thankfully set the stage a little earlier in kind of the distinction between non-point and point. So that's really good. And kind of going back to our home turf at Penn State, and we're in the Chesapeake Bay watershed. I know we're across the Western Divide now into the Ohio Basin and the drainage to the Gulf, but we work a lot on that issue in the central part of the state. And the need for innovations, that we're not addressing the issue as rapidly as we need to, and the needs for innovations associated with that. And really the concept that those innovations really need to come right back down to the local level, because it's about land management, it's about land use, it's about the landowners that impact those lands, and the same in many respects the landowners that are growing the food that relate to a lot of the health issues that we're discussing here this afternoon. So I'm going to give some at least one case study to wrap up of a project that we've led, and now kind of using that as a model in other local communities in Pennsylvania. So the problem related to the Chesapeake Bay, although there's a whole source of pollutants that are of concern, the main thing is nutrients. And we've, root word nutrients, we've talked about nutrition, the importance of health and nutrition. I mean, nutrients are the building blocks of life. They're critically important to sustain life, of course. All of us, critically important to grow the food that we rely upon. So really the problem is too much of a good thing. It's the concept of getting those nutrients into the environment, over-applying them to maximize yields to agricultural lands, perhaps over-applying them in our urban settings to maximize the beauty of our green lawns, those kind of things, and then seeing those nutrients run off, usually associated with precipitation events, but also can volatilize as well into the environment. So it's when that happens, you have the eutrophication effect and excess growth of plant life in the rivers, streams, and water bodies that are affected. So this is excess algal blooms, and when they die off, you have the dissolved oxygen within those water bodies sagging and depleted. And what is the result of that in a cumulative effect, a water body as large as the Chesapeake Bay, are these massive dead zones, particularly in the summer when the blooms are exacerbated, where this goes back about 15 years ago now, the record dead zone, but there's still massive amounts of the Chesapeake Bay, anywhere from 30 to 40% of the water body area of that bay. It's just so low in dissolved oxygen, can't even sustain aquatic life. So it has a cumulative effect that is really a global problem across the world. This is a slide from World Resources Institute that shows areas where you have this atrophic condition within coastal areas, and you see it all around the globe. You see it in developed parts of Europe, you see it in China and other parts of Asia, Australia. It's really a global problem. And it's been defined, really excellent article from a couple of years ago, Patterson and colleagues out of, I believe, the University of Melbourne in Australia, defining non-point source pollution as a wicked problem. That is just one of those difficult problems to solve that kind of cross multiple sectors. It involves and is involved in a complex association with multiple human societal factors. The sources of the pollution are very diffuse. It's not like a single factory emitting toxics. This is something that comes off of the landscape, and we're all contributors toward. And so with all of these factors, it's a real tangled and difficult problem to solve. Just a couple images to kind of set the stage on that. I would also argue that one of the challenges of this pollution source is that the invisible everyone pollutes dynamic. So when the environmental movement kind of was given birth overnight, if you will, in the 60s and early 70s, the signs of environmental pollution that led to that looked something like this. So this is Donora, Pennsylvania, not very far from here, a temperature aversion associated with toxic smog from the zinc plant in that town in, I think, 1948 it was, led to the death of many and illnesses of many more. And those kind of actions that were happening in the United States and even in Europe, London killer smog you'll read about, these were the kind of things that led to passage of the Clean Air Act at the beginning of the 70s. This is another image that you may have seen before, Cleveland, Ohio. This is the Cuyahoga River on fire. We were lighting our rivers on fire. It was 1968, 69. And a couple years later, you had passage of massive upgrades to our pollution legislation, the Clean Water Act. This is an image from Love Canal in New York, close to the Canadian border. Tremendous amount of toxic leaching from an old chemical dump, a community that was built right over top of that. The community knew what was going on. That led to the passage almost overnight of our toxic cleanup waste laws known as CERCLA or the Superfund law. So these are the kind of images that were galvanizing the environmental movement, led to the passage of our kind of environmental law regime. Now, what do the images look like of our nutrient pollution issues? I would submit they look a little more like this. So this, I commend the Patterson article. I also commend this to you, and if you have little ones, they're going to enjoy this book. Maybe some of you have picked this up. My boys are older, but they used to get a kick out of this. But the point is that we're all polluters. We all produce nutrients. We all rely on the food that results in the production of excess nutrients that are causing this problem. Nutrients are captured through the emissions into the air from the power plants that generate our electricity, the vehicles that we drive. And so that's another complication that's going on here. And so because we're all polluters, it really does take this kind of multidisciplinary approach to problem solving. So an approach that's highly collaborative and needs to be very locally led and needs to be led by trusted individuals within communities, particularly as we're talking about rural communities and agriculture, which is the biggest source of this pollutant. These are the kind of approaches that are necessary. And the structures that we have institutionally really are not well set up to address this problem. The conventional wisdom to addressing pollution of our water is fundamentally established under the Clean Water Act. That act has a really bold purpose: to restore and maintain the chemical, physical, and biological integrity of the nation's waters by preventing point and non-point source pollution. So non-point source pollution, preventing it, is written right into the act. There's goals written right into the act. It says goal of zero pollution to our waters. Do you know what date was set when the law was passed in 1972 to achieve that goal? Anyone? 1983. 10 years we'll get it done. No, we're not there yet. And one of the challenges has been non-point source pollution. We do a pretty good job of addressing point sources that come out of a discrete pipe. We can handle those through technology fixes to treat pollution and a permitting scheme to require those dischargers to have permits. In the non-point source arena, we don't really have the mechanisms for that. There are no permits required. What is required is a brand of cooperative federalism, which underpins a lot of our environmental laws. And that's the idea of some standards being established by the feds and then certain duties on the states and kind of this work federally and locally to get it done. But the concept is basically the states develop these non-point source pollution management plans. EPA approves them, provides a little bit of money to implement them, and hopefully it gets done. Well, and the priority is for implementing these strategies in waters that are designated as impaired, they're designated as polluted, and then therefore required under the law to have a cleanup plan established for them, which is called a total maximum daily load, or TMDL. We love our acronyms in environmental law. And so the hope is that this kind of gets done with a plan, throw a little bit of money voluntarily, land managers will take action and get it done. It's not working out so well. This is a report that had a very stark. My little fade-ins are backwards here, I think. There we go. A very stark and blunt title from General Accountability Office a couple years ago. Changes needed if key EPA program is to fulfill the nation's water quality goals. In other words, it's not working. There's no implementation teeth into the program. This is from the Chesapeake Bay TMDL, and there's a whole big cleanup plan that's been established for the Chesapeake Bay, and implementation plans required of each state to develop and implement their plan within that watershed. So massive watershed, 64,000 square miles of land area that drain to the Chesapeake Bay, includes Pennsylvania, and of course Maryland, Virginia, the whole District of Columbia, parts of New York, Delaware, and West Virginia as well. So this is what is commonly referred to as the stoplight chart that EPA updates every year. They look at progress toward meeting those cleanup goals. And whenever you see a chart like this, you don't want to be red, okay? So Pennsylvania is, there we are, we're red, meeting agricultural goals and urban stormwater goals. But part of it is just the massive amount of the problem we have. This shows a map of the drainage, a heat map that shows nitrogen sources coming off the landscape, and you could overlay the agricultural lands really easily there. And so these charts show the priority areas, and they overlay where we have a high intensity of agriculture, particularly animal agriculture. So what we've found is in a watershed where in Pennsylvania alone, we need to work with approximately 33,000 different farms. That's how many individual farms we have in Pennsylvania's portion of the Chesapeake Bay watershed. The idea of kind of locally led efforts in priority areas. So we've been focusing largely in Lancaster County, which if you know county lines, you can basically see the outline of Lancaster County in that red square in the southeast there. Highly intensive agriculture together with urbanization as well. And so what we've done, and this is a watershed in that area where we've led some efforts over the years and continue to do so. The whole idea of pulling multiple partners together in a watershed, almost building a watershed community, and bringing Penn State's integrated research and extension and outreach and education, getting students involved. And our big hypothesis is, can we create a local diverse partnership that can restore a watershed. And our hypothesis being we can get more done if we all work together. So the partnership has grown through the years. It includes public and private sector, federal to local involvement. We have a bit of an organizational structure around that with a committee that's kind of a managing committee, and then different individuals. And I am out of time, so I'm going to have to just blow through these last pieces. The model is really increasing outreach and engagement to get folks aware of the importance of land management practices, things they can do on their own farms and backyards to improve water quality, getting out into the community to do that, and then really communicating the value of good stewardship of lands to provide ecosystem services, not only helpful to the farmer, but to all of us. And we used storybook concepts there of actual farmers in that watershed telling their stories in a produced set of stories from the Conewago. And then providing the technical assistance, folks from USDA, local county conservation districts, Penn State Extension, to help farm managers improve the conservation of their farms. And we saw real high bump ups in the amount of best management practices installed for water quality associated with that, with increased rates of adoption once the partnership was formed locally. And then monitoring the success of that. We've able to get out in the stream and sample some of the fish and see a jump up in fish diversity species, as well as the aquatic insect indicators of stream health. And that also has a feedback loop to the educational component, because the community can kind of get involved and see what's actually being produced in their local streams. So I just have a couple pictures worth 1,000 words to wrap up here. Some of the projects that we've done on sites to turn them into impacted, adding aquatic and ecosystem habitat and recreational opportunities. This is another farm that had direct cattle access, and it's now healthier for the cows because they're fenced out, and then with plantings along the stream, 10 years later, you have a mini forest growing along that stream. It's helping to control floodwaters. That farmer won a state award for that project. And you're taking a little bit of land out of production, but it's marginal land, and with things like fencing, that farmer is still able to use the majority of that land. So you're kind of improving the watershed ecosystem health, and at the same time supporting viable, productive agriculture. So thank you. Sorry for taking the time.